Welcome back to Mathematics Lifeline. In today's video, we're going to integrate 1 over the square root of x plus the cube root of x dx. Now, as you may have seen from the title, you know the strategy we're going to use to start this integral. It's going to be a substitution. But let's talk about why we need to use substitution and how we can figure out the best substitution to make here. So we see that we have a rational function, and we know there's a lot of ways we can work with rational functions. There's a lot of options that we have, but most of those options will consist of the numerator and denominator having whole number powers. So if we look at the degree of the x's, we usually will see whole numbers, not fractional exponents like what we have here, because these square roots are fractional exponents. So we want to choose a substitution that's going to help us get this denominator in terms of a u with a whole number exponent. So we need something that's going to have it's going to be a common multiple of the square root and the cube root. Well, we know that 2 and 3 both have, well, it's their least common multiple actually is 6. So what we're going to do is we're going to choose u to be equal to the 6th root of x, which of course is equal to x to the 1/6 power. Now, the reason we're doing this, and it may not be clear right now, but we want to eventually sub something in for x. So the way we can do that is we can actually raise both sides to the 6th power. And we'll get a solution in terms of x because these will cancel each other out. And we're going to get u to the 6th is equal to x. Now this is helpful because now we can actually put u to the 6th under the square root and under the cube root, and we're going to get a whole number power. But remember that because we're doing the substitution like this, we need something for dx to be changed out with. But it's nice because we have something just in terms of x, so we can just take the derivative. So dx is going to be the derivative of u to the 6th, which is going to be 6u to the 5th du. Okay, this is helpful because now we're going to rewrite this integral as the integral of, well, dx got changed out with 6u to the 5th du. So we're going to have 6u to the 5th over, we're going to have the du out here. Now when we plug in x equals u to the 6th, so we have the square root of u to the 6th. Well, that's going to be u cubed. Plus, then we have the cube root of u to the 6th, which is going to be u squared. And you can check that because this is x to the 1/3, or u to the 1/3, u to the 6th times 1/3, right? The 6 times 1/3 is in the exponent, so it will become a u squared. So we've now substituted everything in for u, and we now have whole number powers, and this is really helpful because now we can proceed with this integral. So what I'm going to do is I'm going to pull the 6 out front, and I'm also going to factor out a u squared from the top and the bottom. So we have 6 times the integral of u squared times u cubed over u squared times u plus 1 du. So that's just factoring u squared out of everything. And the nice thing now is that these will cancel out. So what we have is 6 times the integral of u cubed over u plus 1 du. And at this point, we can actually just go ahead and use polynomial long division to get something in terms of a nice function to integrate, essentially. So we're going to divide u cubed by u plus 1. Now, if you don't remember this process, remember we take u and we see how many times can it go into u cubed. Well, it's going to go in there u squared times. If we multiply these two, we'll get u cubed. Now we're going to go ahead and multiply everything out, and we're going to subtract off what we get. So u squared times u is u cubed, and then we have a plus u squared. So these will cancel out, and we have a 0 minus u squared, which gives us negative u squared. Now the same process. How many times can u go into negative u squared? It's going to be minus u times. So then we multiply, and we get a negative u squared, and then we'll have a minus u. And we subtract, these cancel. This becomes a positive u. And now, of course, this can go in plus 1 times. Now we'll multiply again and subtract, so we'll get u plus 1. So we're left with negative 1, which means we have a remainder of negative 1. Now what that tells us is that the quotient that we have here comes out to u squared minus u plus 1 with a remainder of negative 1. So when we want to write that in the integral, here's how we'll do it. So I have 6 times the integral of u squared minus u plus 1, and the remainder is a negative 1. So what that is just going to be a plus negative 1 over u plus 1. Just remember that's what we divided by. Now you can see that this is very nice because everything here is pretty simple to integrate. Even this one, it may not look simple, but that's just a natural log argument. So we're going to go ahead and integrate. So we have 6 times, well, the integral of u squared is 1/3 u cubed, minus 1/2 u squared from integrating this one, plus u, and then we have minus the natural log of the absolute value of u plus 1. Let me get this out of the way here. So this is what we have when we integrate what's inside. And remember, that's in terms of u, but we're still going to go ahead and multiply our 6 out real quick before we sub our x back in. So here we're going to have 2u cubed minus 3u squared plus 6u minus 6 times the natural log of the absolute value of u plus 1. So that's what we have, and we're going to add the plus c at the end. But we want to go ahead and sub our u back in for a function of x. And remember, we chose the 6th root of x whenever we did that. So what we're going to have here is now it's 2 times the 6th root of x cubed. Well, that's going to be 2x to the 1/2, or 2 square root of x. Either way, when you multiply those together, when you multiply the powers and the exponents, you're going to get 1/2. Same thing here. We're going to have minus 3x. Well, if we have the 6th root of x squared, we're going to get the cube root of x, or x to the 1/3 power. Now right here, we're just going to have plus 6x to the 1/6, and then we're going to have minus 6 times the natural log. I'm going to use parentheses because what we have as u is the 6th root of x, which is always positive, plus 1, so it's going to stay positive. And we'll need the plus c. So writing this to where we keep it consistent with all of these terms, we're going to have 2 times the square root of x minus 3 times the cube root of x plus 6 times the 6th root of x minus 6 natural log of the 6th root of x plus 1 plus c. So it's a very long answer here. But it's pretty systematic once we made that original substitution up here. Once we got the substitution to work out, it's fairly systematic how we follow here. So yeah, I wanted to show this integral. I didn't want to do it in the integration practice series because I think it's a little bit too creative for that one. You kind of have to think about this one for a while. It's not very systematic. This probably wouldn't be on very many exams. So, but I think this is a fun integral. Hopefully you were able to do it. If you were, of course, let me know in the comments. And if you do have any questions on what we did today, of course, let me know as well. And I'd be glad to answer. But if not, then I will see you in the next video. Thanks for watching.